so the temperature of a 12-ounce cup of coffee at time t, so t is measured in minutes since the coffee was brewed, is given by that function there. For the range 0 to 10 minutes. Interpret the meaning of the following in context of the situation. What is the meaning of T of 9 minus T of 4? So T of 9 is the temperature at 9 minutes, and T of 4 is the temperature at 4 minutes. So this is the change in temperature from T equals 4 minutes to T equals 9 minutes. So this is telling you how much the temperature changed in that 5-minute interval. What is the practical meaning of that? So that would be the, so this would be the approximate rate of change. So this is, so on top here is the change in temperature, and this is the change in time. So this is the approximate rate of change in temperature at T equals 4 minutes. And the rate of change is measured in degrees Fahrenheit per minute, because T is measured in minutes. What is the practical meaning of the equation? T prime of 4.2 equals negative 9.85. So 4.2 is a value of time, and negative 9.85 is a value of the derivative. So this is a rate of change. So the practical meaning of that is when T equals 4.2 minutes since the coffee was poured, the temperature of the coffee is decreasing at a rate. Actually, I'm going to say the temperature is changing at a rate, and that way I can use the negative number. That way I don't have a double negative. At a rate of negative 9.85 degrees Fahrenheit per minute. That means if we left it out for an additional minute, it would change by approximately 9.85 degrees lower. It would go down by about that much. Use the limit of definition of derivative to show that dt is t minus 12. So let's go back. Let me write the function down. So it's t is 1/2 t squared minus 12t plus 90, I think. 190. Okay. So that is the function, and I want to use the definition of derivative. Okay, so we'll say the limit as h goes to 0 of t plus h minus t of t over h. So if I plug t plus h in, I have the limit as h goes to 0 of 1/2 t plus h squared minus 12 times t plus h plus 190 minus 1/2 t squared minus 12t plus 190 over h. Okay, and again, I have to keep writing that limit there. So I have 1/2, and then if I multiply out t plus h squared, it's going to be t squared plus 2th plus h squared. So you'll just have to multiply that out and FOIL it. And then I'm going to go ahead and distribute that negative 12 into both of those. So minus 12t minus 12h plus 190. And then I'm going to go ahead and distribute this minus sign into everything too. And so I have minus 1/2 t squared plus 12t minus 190 all over h. So I get the limit as h goes to 0. Now I'm going to distribute the 1/2 into each of those guys. So 1/2 t squared plus 2, so 2 times a half is 1. So plus th plus 1/2 h squared minus 12t minus 12h plus 190 minus 1/2 t squared plus 12t minus 190. So one thing you might notice, as you may have come to expect, is that all the things over here are going to have, a term. Oh, shoot. I meant to undo that. So this should be minus 1/2 t squared. Should have a corresponding term that is the opposite sign. So 1/2 t squared minus 1/2 t squared. Those two things are going to add to 0. And then if I have a positive 12t, I also have a negative 12t, so those things are going to add to 0. And then that negative 190 and positive 190, those things are going to add to 0. And so you can just kind of match up those corresponding bits there. That's all over h. So I get the limit as h goes to 0 of th plus 1/2 h squared minus 12h, all over h. And one thing you might notice is that there is a common factor in these top terms here. I have an h in each of those. And so what I'm going to be able to do is factor out that h. And why do we want to do that? Well, I can't just directly plug in h equals 0 here because I have a h in the denominator. And if I plug in 0 for the denominator, then that would give me something undefined. So what I'm doing is I'm working algebraically to get rid of that h in the denominator, and I'm almost there. So if I pull out an h from that, I have t plus 1/2 h minus 12 all over h. And now h divided by h gives me 1. So those two divide to make 1. So I'm just left with the limit as h goes to 0 of t plus 1/2 h minus 12. And now I no longer have that issue with that h in the denominator. And so at this point, I can go ahead and plug in h equals 0. And if I do that, I get t minus 12. And that was the result I was trying to get here, that the derivative is equal to t minus 12.